Let's going to learn about line symmetry. What is line symmetry? Look at this example. We have a triangle. We can divide it to be two parts. We can draw a line like this. The line divides the triangle to be two parts, with the left and right side with the same sides. If you can fold the figure in a half so that two halves exactly match, the figure is said to be symmetrical. Remember that the left side and the right side must same, equal size. And the line that break the shape called with line symmetry. Let's draw the line symmetry for the given figures. Here is rectangle. Let's draw the line symmetry vertically and horizontally. So, a rectangle has two lines of symmetry. Then, how about square? Let's draw the line symmetry. 1, 2, 3, 4. So, a square has 4 line symmetry. Look at the other example. Here are some figures, some pictures. There are apple, arrow, butterfly, flower, heart, and house. All draw line vertically. So, all this picture has one line symmetry. How about the other example? Look at the heart. The heart has one line symmetry, and the isosceles triangle has 3 line symmetry. Square has 4 line symmetry, and circle infinite number of line symmetry. You can fold anywhere to make it same. The next is reflection. Look at this triangle. The interaction is to reflect the triangle over the y-axis. The y-axis in the middle line. And reflect it face to face, and the distance must same. The red one, this distance is 1 step from y-axis, so the blue one is 1 step too. Continue with rotational symmetry by watch this video.
A figure has rotational symmetry if you can rotate, turn it, and have it look the same as when you started. For example, you can turn the star above 5 different ways, and it will look exactly the same. Or you can think of it this way. This triangle, however, does not have rotational symmetry. If you rotate it, it will not look exactly the same. The order of rotational symmetry is the number of positions you can turn the object and still have it look exactly the same. If it looks the same in 2 different positions, it is order 2. If it looks the same in 3 different positions, it is order 3. Point symmetry, or origin symmetry, occurs whenever a figure has order 2 rotational symmetry. This means that each point on the object has a corresponding point that is the exact same distance from the center point, but in the opposite direction. Examples. Determine if each figure has rotational symmetry, and, if so, what order. This flower does have rotational symmetry because it could be turned and would look exactly the same. It could be turned 5 times, so the order is 5. This figure does have rotational symmetry because it could be turned 180 degrees and would look exactly the same. The order is only order 2, though, because it could only be in 2 positions. The one it is now and upside down. Remember that whenever a figure has order 2 rotational symmetry, it has point symmetry or origin symmetry. That's because each corresponding point is the same distance from the center point, but in opposite directions. This stick figure does not have rotational symmetry. If you turn him, he will not look the same as he does now. He'll be crooked, sideways, or upside down. This figure does have rotational symmetry because it could be turned and would look exactly the same. It could be turned 3 different ways, so the order is 3.
Let's continue with direction. Look at this arrow. This is left, then right, backward, and forward. When you see the map, you always look the symbol of direction. Do you know the direction? Yes. The first is north, and then south, west, and the right is east. Now continue with clockwise and anti-clockwise direction. Look at this clock. The hand of clock is moved to the right, so you can call it with clockwise. And when the direction is opposite with the clock or to the left, you can call it with anti-clockwise. Now let's continue with turning by watching this video.
Hi and welcome to our lesson on clockwise and anti-clockwise turns. We'll begin by looking at quarter, half, three-quarter and full turns. The car will turn in this direction. This is a quarter turn, half turn, three-quarter turn and full turn. We'll look at using these turns in clockwise and anti-clockwise directions. Here we have an analog clock. The direction that the hands turn around the clock is called clockwise. The opposite direction is called anti-clockwise. This can also be called counterclockwise. This car will move a quarter turn clockwise. The car will turn in this direction. This is the same direction as the hands of a clock. This is a 1/4 turn clockwise. This time, the car will take a quarter turn anti-clockwise. So the car will turn in this direction. This is the opposite direction to the hands of a clock. The car takes a quarter turn in this direction. This time, the car will take a half turn clockwise, so in this direction. Now it will take a half turn anti-clockwise, so it will turn in this direction. You may have noticed that both a half turn clockwise and a half turn anti-clockwise result in the car facing in the opposite direction to where it started. This also means that when doing a half turn, it doesn't make a difference if we move clockwise or anti-clockwise. The car will still end up in the same position. Next, the car will take a 3/4 turn clockwise. So the car will turn through 3/4 in this direction. Now it will take a 3/4 turn anti-clockwise. So this time it will turn in this direction. Finally, we will look at full turns. First, the car will make a full turn clockwise. This means that the car will turn in this direction. So this is a full turn in a clockwise direction, and the car ends up back in its starting position. This time, the car will make a full turn anti-clockwise, so in the opposite direction. Again, the car ends up back in its starting position. As we can see, with full turns, it doesn't matter whether the turn is clockwise or anti-clockwise. The result is the same. The car will end up in the same starting position. Here are some questions for you to try. Show which direction the car would be facing if it made the following turns. An accompanying activity sheet is available to download and print for these questions. Pause the video now and have a go. Question 1. A quarter turn clockwise. Question 2. A quarter turn anti-clockwise. Question 3. A half turn clockwise. Question 4. A 3/4 turn anti-clockwise.